Welcome pre-Cal students to the homework help video, page 859, numbers 1 through 47 odd. Go ahead and get your homework out, your books, notes, calculators, pens, pencils, whatever you need, and let's go ahead and get started. Let's take a look first of all at numbers, let's see here, 1 through 7. Numbers 1 through 7, the odds and the directions read as follows. Find the first term and the common difference. So just ignore these formulas right here. I just have those there so at any time I can cut and paste those and use those throughout the assignment. Okay. All right. First of all, the directions say find the first term, and obviously the first term, a subscript 1, is 3. Right here. And then notice we're increasing by 5. 3 plus 5, 8 plus 5, 13 plus 5. And of course we use D for common difference, and D equals 5. Easy enough. Number 3. All right, at number 3, they want to know what the first term is, and they want to know what the common difference is. Well, your first term is obviously 9, and your common difference, notice here, we're increasing by 4. Going down 4, going down 4, going down 4. So really what you're adding is not 4, but you're adding a negative 4. You're adding negative 4 over and over and over. So your common difference is negative 4. And by the way, if you can never figure out what the common difference is, first of all, don't forget, you never have a common difference unless it's an arithmetic sequence. And if it is an arithmetic sequence, you will always have a common difference. And what you do is you can circle any number in the sequence and then subtract the other number from it. So 1 minus 5 is negative 4. Or you could subtract this number here, and negative 3 minus 1 is negative 4. So that's one quick way to find the common difference if you're ever confused. And we'll probably do that right now with number 5. Now number 5, the first term is obviously 3 halves. That's easy. So a subscript 1 is 3 halves. And then you can circle any number you want. I'm going to circle this one and subtract from it the term right before it to the left of it. So 9 over 4 minus 3 halves. Now that would be the same thing as 9 fourths minus 6 fourths. And what you would get is 3 fourths. 9 minus 6 is 3. So your common difference is 3 fourths. And now let's check and make sure that's right. If you take 3 halves and add 3 fourths, you will get 9 fourths. If you take 9 fourths and add 3 fourths, you will get 3. If you take 3 and add 3 fourths, you will get 15 over 4. So all of this works just fine. All right. Number 7, the first term is $316. And then to me it's pretty obvious we're decreasing by 3. Decreasing by 3, so that means we're adding a negative 3. So your common difference is a negative 3. All right, let's take a look now at number 9. Number 9 says, of course the answers are right here, just ignore that, okay guys? Let's go ahead and get our formulas up right here. We might need those. So there's our formulas, and here we go. Don't forget, this is for the nth term, and this is for the sum of an arithmetic sequence when you're adding a bunch of numbers together. Find the 12th term of this arithmetic sequence. Now, if you wanted to, this is the first term, this is the second term, this is the third term, you could keep adding 4, 4, 4, 4 over and over until you got to the 12th term. That's fine, but really what if I asked you to find the 150th term? Then that method is really not going to work. So what I'm going to do is I'm going to quickly find the nth term, and the nth term is, right here's my formula. First comes a subscript 1, that's your first term, so 2, plus, and then n minus 1, and then your common difference, and of course we're adding 4, so your common difference is 4. There, I found my nth term. Now, using this formula right here, now quickly I can find the 12th term by putting a 12 in for n. So a subscript 12, the 12th term equals 2 plus 12 minus 1 times 4. And of course, if you simplify, it would be 2 plus 11 times 4. Then you multiply first. 44 plus 2 is 46. All right, let's take a look at number 11. Find the 14th term. Okay, well, first of all, we're going to use our formula here of the nth term. So let's quickly write our nth term. Our nth term would be a subscript n equals your first term, that would be 3, plus n minus 1, and then your common difference. Now to find your common difference, you always circle any term you want to. I'm going to circle this one and subtract from it the term immediately to the left. So 5/3 minus 7/3 is negative 2/3. So the common difference here is going to be negative 2/3. So I'm going to put a negative 2/3 right here. And why do I put it here? Because look at your formula. Here's where your first term goes, and notice I put it right here. Here's where your common difference goes, and notice I put it right here. What about n? Well, n stays n. N just represents whatever term you're going to be dealing with. Now, let's go ahead and quickly find the 14th term. So 3 plus, and then 14 minus 1 times negative 2/3. And then, of course, it'd be 3 plus 13 times negative 2/3. Then we do multiply first. So 3 plus, and then a positive 13 times a negative 2/3. Use your calculator if you need to. It'd be a negative 26 over 3, and then go ahead and feel free to use your calculator. 3 plus a negative 26/3. By the way, when you type it into your calculator, be sure and put parentheses around negative 26/3. But I'm trying to do it in my head here. If you do it correctly, you'll get 9 over 3. 9 minus 26 is negative 17/3. So you will get negative 17/3, which is the correct answer. And if some of you got negative 5 2/3, that's also acceptable. That's the exact same answer. All right, let's take a look now at number 13. Okay, now students, take a look at number 13. Find the 10th term of the arithmetic sequence. And so let's pull our formulas up here. And again, you could write out the terms until you got to the 10th one. That's fine. I just recommend we quickly find the 10th term. And plus, it's good practice because I might ask you on a test to find the 50th term. And that would take quite a while to write out 50 terms. So a subscript n equals a subscript 1. That would be 2,000. Not sure why I put a 3. $2,345.78 plus n minus 1, and then your common difference. Now, to find the common difference, you take any term that you want and subtract from it the term previously immediately to the left. So I've got my calculator out here, 2967.54 minus 2345.78, and the common difference is this right here. The common difference is 621.76. Now we're going to find the 10th term, so I'm going to save a little bit of time because these numbers are big. I'm going to get this n out of here, and where that n is, I'm going to put a 10. All right, so 10 minus 1 would obviously be 9, and then if you take 9 times 621, you're going to get this right here. You will get 5,595.84, and we're going to add to that 2,345.78. Let me quickly do that for you. 2,345.78, and I know my answer here looks like it's 794, but actually it was cut off, and so I do have the right answer. It's 7,941.62. So that is the correct answer, and you'll get that if you add these two numbers together. Okay, number 15. In the sequence of exercise 8, what term is the number 1.67? Now we're going to have to go back and look at number 8, and if you'll look at number 8, I'm going to quickly write the nth term for you for number 8. So your book should be open to the proper page. If you'll look at number 8, here's the nth term. The nth term would be a subscript n equals your first term, which is 0.07 plus, and then n. Does everybody follow what I'm doing here? You should be looking in your book at number 8. Number 8. In number 8, the first term is 0.07, and the common difference would be 0.05. So 0.05. I'll put parentheses around it so there's no confusion. Now we're going to find the 30. No, what term is 1.6? what term is 1.67? Okay, now be careful. Listen to me, and I'll explain this well. If the answer is the 33rd term, now listen, if they said to you, find the 33rd term, then where n is, you would put 33 like we did for the past 2 or 3 problems, and you would find the 33rd term. However, pretend you don't know what the answer is. They're not asking you to find what the 33rd term is. They're saying one of the terms is 1.67. Find what term that is. So you come over to a subscript n, and you put 1.67, and now you're going to solve for n, because n is the number that shows you what term you're dealing with. So we're going to solve for n. Hopefully you see the difference there. So 1.67. Now be careful here. There should be a plus sign right there. First of all, you want to take your 0.05 and multiply it through. So 0.05 times n would be 0.05 n, and 0.05 times -1 is -0.05. Now you see how you have two like terms over here on the right side of the equation, so we're going to go ahead and put those together, and now we have 1.67 equals 0.02 plus 0.05 n. Now let's bring over the 0.02, and when we do, it becomes a -0.02, and now it's gone, and I'm left with 0.65 equals 0.05 n. Now feel free to use a calculator. If you divide both sides by 0.05, you will get 33 exactly. And so 33 equals what? It equals n. So that's what term number you're dealing with. So the 33rd term is 1.67. Study this. Make sure you know how to do this, okay? All right, let's continue on now to number 17. Some of these pictures are really blurry and faded. I'm not sure why that happened, but nonetheless, we'll try to do the best we can. Number 17 says, in the sequence of exercise 11, what term is -27? So let's go back to number 11 real quick. We have our nth term, do we not? Here it is right here. And so let's kind of scroll down. Here's our nth term already. We already know the nth term for number 11. So let's take that nth term and let's drag it right over here. So in exercise 11, here's your nth term. What term is -27? So again, for a subscript n, we're going to put -27 equals 3 plus, and now take your -2/3 and multiply it through. Actually, I shouldn't have put a plus sign there, because -2/3 times n is -2/3 n, and -2/3 times -1 is a +2/3. Now combine your like terms on the right side of the equation, and you would have 3 plus 2/3 is 3 2/3, that's 11/3, minus 2/3 n. So I combined 3 2/3 and got out 11/3. Use a calculator if you need to. Okay. Now I'm going to bring the 11/3 over and make it a -11/3. So if you do that correctly, you're going to get -92 over 3, or 30 2/3 is acceptable, equals -2/3. Now with your calculator, feel free to now divide -92/3 divided by -2/3. And if you do that correctly, you are going to get out 46. Okay, you will get out 46. And of course, a negative, I'm going to go ahead and set this up for you, being divided by -2/3, divided by -2/3. These cancel. Go ahead and use a calculator if you need to, and you will get out 46 equals n. So the 46th term is -27. All right, number 19. Find the first term. Now this will be interesting. Find the first term when d equals 4, and that's the common difference, and the 8th term equals 33. Now let's be really careful. We can use our formula right here. We can use this, okay? Watch carefully how I use it. Watch. A subscript n equals a subscript 1 plus n minus 1 d. Now watch. I can actually find the first term. You can, Mr. Earhart? Yeah, most definitely. The 8th term is 33. So for a subscript n, I'm going to put 33. That's the actual term. I don't know the first term. That's what I'm looking for. For n, I would put 8, right? Sure, because the 8th term is 33. N is what term number it is. A subscript n is the actual term. Minus 1. Now what would I put for d? I would put a 4 because my common difference is 4. So I only have one unknown. It's a subscript 1. So 33 equals, here we go, a subscript 1. Now we can do this in our head. 8 minus 1 would be 7. 7 times 4 is 28. Now bring the 28 over and make it a negative 28. And you're left with 5 equals a subscript 1. So the first term is 5. And you could have done it another way. You could have if you're adding 4, you could have subtracted 4. The 8th term is 33. You could have subtracted 4 over and over and over until you got to the first term, and that's fine. Actually, it's not fine because on the test, I'm going to make sure I give you such large term numbers like the 50th term and stuff like that that you're not going to be able to do it that way. I want you to get used to using these formulas so you can solve them quickly, okay? But that's how you would do that. Number 21, find n. All right, when a subscript 1 equals 25, the common difference is negative 14, and a subscript n is negative 507. Now, can I tell you something? All it's saying to you is this. Can I reword it for you? All it's saying is this. What term number is negative 507? What term number? So here we go. It's like we've done before. They're giving you the first term, it's 25. They're giving you the common difference, it's negative 14. All they want you to do is find what term number negative 507 is. So for a subscript n, I'm going to put negative 507. For a subscript 1, I'm going to put 25. For n minus 1, I'll put n minus 1. And then for common difference, negative 14. Now let's solve this. Here we go. Negative 507 equals 25. Now be careful here. Negative 14 times n is a negative 14n. And a negative 14 times a negative 1 is a positive 14. Now combine these two like terms right here. 25 plus 14 is 39. So we have negative 507 equals 39 minus 14n. Now bring the 39 over, and when you do, make it a negative 39. And you'll have a negative 546. Negative 507 minus 39 more is negative 546 equals negative 14n. And now we're going to divide both sides by negative 14, and you will get 39 for n. So there, you found it. You found what term number negative 507 is. Negative 507 is the 39th term. There we go. Pretty simple. All right, number 23. In an arithmetic sequence, they give you the first term, the 17th term, and the 32nd term. Now watch this. They want you to find the first term and the common difference, and then write the first 5 terms. Now students, come on, think about this. If the 17th term is 25 over 3, and wait, and way over here is the 32nd term, which is 95 over 6. If I take those two numbers and subtract them, I'm going to take 95 over 6 minus 25 thirds, and I'm getting 15 over 2, or 7.5. So the total distance from here all the way to here is 15 over 2. That's the entire distance isn't the right word. That's the total difference. How's that? That's the total difference from here to here. But hold it. That's not one term. That's 15 terms. You went from 17 all the way to 32. So I've got to take this total difference and divide it by 15 to find what the little common differences are over and over. Okay, do you see that? The total difference from the 17th term to the 32nd term is 15 over 2, 7.5. But I want to find out what one little difference is, okay? So, watch this. I'm going to take 15 over 2, and since there's 15 terms from here to here, I'm going to divide it by 15. All right. Now, if you divide by 15, you can use your calculator. You will get 1/2. So now you know what the common difference is. The total difference from here to here is 15 over 2 divided by 15. And now you know you were adding 1/2 over and over and over until you got to the 32nd term. So here's what I just found out. Are you ready? I just found out this. Let's write down what we know. We know our 17th term. We know our 17th term is what? 25 over 3. We know that right here. We know our common difference is what? 1/2. You know what? I'm ready to use my formula, and I'm ready to get to solve this thing. Watch how I do this. I mean, this is pretty, didn't mean to do that. This is pretty simple. I'll leave my term up here. Actually, I shouldn't have done that. Hold on one second here. I'm going to go ahead and slide this down here, and we'll pull this back up here. And now watch what we do here. Okay, this is actually pretty cool. Watch this. I'm going to use this good old formula again for the 100th time today. A subscript n. Now hold it. I'm going to get rid of this formula for a second. It doesn't matter what term. You could actually use the 32nd term if you wanted to. I chose to use the 17th. For a subscript n here, it's the 17th term. Watch what I put. I'm going to put 25 over 3. Mr. Earhart, are you allowed to do that? Yeah, you're allowed to put that there as long as you realize your n over here will be what number? 17. If the 17th term is 25 over 3, you can put 25 over 3 right here as long as you put 17 for n. Now your first term is what you're looking for, so we'll leave that alone. For n, I'm going to put 17 because 25 over 3 was my 17th term. And then for common difference, we found that already down here. The common difference is 1/2. So you know what? Let's get to work. Here we go. 25 over 3 equals, I'm not sure why I put a equal sign here, should be a plus sign, equals a subscript 1 plus, now do this in your head, 17 minus 1 is 16, 16 times 1/2 is 8, okay? Now bring your 8 over, and when you bring it over, you'll make it a -8, and I think you're going to get 1/3. Let me use a calculator here to make sure, just to make sure. Yes, you get 1/3. So 25 over 3 minus 8 is 1/3, which is your first term. Okay, so there we go. Now I'm not going to take time and list out these first 5 terms for you. Here's your common difference. We found that right here. Here's your first term right here. We found that. Then they want you to list out the first 5 terms. Well, guys, you know how to do that. The first term is 1/3. And then what's the common difference? 1/2. So take 1/3 and add 1/2 and you'll get 5/6. I'm not going to do that work for you. Add 1/2 and you'll get 4/3. Add 1/2 and you'll get 11/6. You can use a calculator on all of this. Add 1/2 and you'll get 7/3. Okay, so there we go. Let me grab a quick drink of water here and we'll continue on. Number 25. Okay, now we're getting into the fact to find the finding sums. Okay, and that's where we're going to use this other formula now. Now remember this, now listen to me. This formula only works when you're finding the sum of an arithmetic sequence. If you don't have an arithmetic series that you're adding, then don't use this formula. Okay, now do we have an arithmetic series? Let's see, we're adding 3, adding 3, adding 3. So yes, we do have an arithmetic series. We're going to find the sum of the first 20 terms. Got it? First 20 terms. So here's my formula right here. Here's my formula. All right, here we go. We're adding 20 terms, so the sum of 20 equals, now what I put for n, 20, I'm adding 20 terms, so for n right here I put a 20. That's how many terms I'm adding up. What's my first term? And by the way, this formula is wrong. It's a subscript n, and I apologize. Okay, it's totally my fault. Your first term is 5 plus, and this is a, there's an n right here, so a subscript 20. Oh, we got to find the 20th term, don't we? Wow, this is going to take a little bit of, I didn't realize that. We got to find the 20th term. So we'll have to come over here, and we've got to very quickly find the 20th term. Do you see what I'm saying, students? The formula here says we need the first term, and we need the last term. If you don't know those two terms, you can't find the sum. Well, we know the first term is 5. We don't know what the 20th term is. So, real quick, I'm going to write the nth term, then find the 20th term. The nth term is a subscript 1 is 5 plus n minus 1. What's my common difference? I'm adding 3 over and over. And now we're going to find the 20th term real quick. So the 20th term would be 5 plus 20 minus 1 times 3. So 5 plus 20 minus 1 is 19. 19 times 3 is 57. And so the 20th term is 62. So I'm going to come over here and put 62. That's the 20th term. And now we're all set. 20 divided by 2 is 10. 5 plus 62 is 67. And 10 times 67 is 670. So just like that, you found the sum of the first 20 terms of this series. Now you could have written out all 20 terms and then with the calculator added them up, but these formulas do make it a little quicker. Okay, let's move on to number 27. All right, now on number 20 here, let me get our formulas up here. It says find the sum of the first 400 even natural numbers. Now natural numbers start at 1 and they're integers. So 1 plus 2 plus 3 plus 4. But it says the first 400 even natural numbers. So what we're trying to find the sum of here is 2 plus 4 plus 6 dot 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 until we get up to the 400th term. Does that make sense? So here's what we're going to have to do. First of all, we're going to have to find, remember to do the sum here, I'll go ahead and start filling this in, but you're going to see in a second, in order to find the sum, we have to know the first and the last term. We don't know that 400th term. Let's go ahead and fill in what we know. Okay, we're going to find the sum of 400 numbers equals 400 over 2. Now we have to know the first term, which is 2, and we have, this should be an end, don't forget that's a typo. And we should know the last term too, and we don't know the last term. That's the 40th term. We want the, or the 400th term. So I come over here and I write my nth term. My nth term is, my first term is 2 plus n minus 1. Now what's your common difference? 2, 4, 6, you're adding 2, so your common difference is 2. Now we're going to put 400 in for n, so 400 minus 1 times 2. So 400 minus 1 would be 399 times 2, which would be 2 plus 8 carrier 1, 9 carrier 7, 98, so 800. So your 400th term would be 800. All right. So here we go. Let's find. Everybody see how I did? I found the nth term, and then once I knew the nth term, I then put 400 in for n to find the 400th term, and now I know what the first term is. Now I know what the 400th term is, and now I can use this formula. By the way, why can I do all of this? Because I have an arithmetic sequence. If it was not an arithmetic sequence, you could not use these two formulas. How do I know it's an arithmetic sequence? Because it says 2 plus 4 plus 6 plus 8. I'm adding the same number over and over and over. All right, real quick, 400 divided by 2 is 200 times 802. All right, so 200 times 802 would give us 160,400, which is the correct answer. All right, and moving on to number 29. Wow, that's a really clear picture there. Find the sum of the multiples of 7 from 7 to 98, inclusive. That means include 7 and include 98. So find the sum of the multiples of 7 from 7 to 98. So we have 7. This won't take too long to write out. 14, 21, 28, 35, 42, 49. You know what? This might take longer than I thought. We probably should use the formulas. I'm probably setting a bad example, but I think I can do this faster than the formulas. Let's see, 56, 63, 70. I'm almost there. 77, 84, 91, 98. All right, so we're going to add up all those terms. 7 is a subscript 1, and 98 would be a subscript, I don't know, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 terms. Now, I'm going to find the sum. I'm going to find the sum of these numbers. But first of all, let's make sure I have an arithmetic sequence. Am I adding 7 over and over? Yes, I am. So I can use my sum formula right here and find the sum of all these numbers. So there's 14 terms altogether, so the sum of 14 terms equals 14 over 2. Your first term is 7. Your last term is 98. 14 divided by 2 is 7 times 105. And 7 times 105 would be 735, which is the correct answer. All right, number 31. If an arithmetic series has a first term of 2 and a common difference of 5, and I can't read it, and the common difference, and the 20th, and n equals 20, what is the sum? Okay. All right, here we go. This is going to be a good one now, so really pay attention. It's going to be challenging for you. All right, let's start off by splitting our two formulas up here and using them. So here's my nth term formula, and here's my sum formula, as long as we fix this 2 right here and make it an n. So get rid of that, and we put an n there. All right, let's start off with my nth term. I think we should write the nth term. I think that will help us, okay? So my nth term is a subscript n equals my first term, which is 2, plus n minus 1, and my common difference is 5. There, that's easy. I wrote my nth term. Now look what it says. They want us to find the sum of s subscript n. And what is n? N is 20. So really they just want us to find the sum of the first 20 terms. That's what they're saying. What is the sum of s subscript n? And of course s subscript n just means the sum of n, and n is 20, so we're finding the sum of the first 20 terms. So if we're finding the sum of the first 20 terms, that would be 20 equals, sum of 20 equals 20 over 2. Your first term is 2, and our last term we don't know. We can find it real quick. Put a 20 in for n, and we'll have our 20th term. 20 minus 1 is 19, and 19 times 5 is 95. So 20 minus 1 is 19. 19 times 5 is 95, so 2 plus 95 is 97. So I know my 20th term is 97. So 20 divided by 2 is 10. 2 plus 97 is 99, and 10 times 99 is 990. There we go. Very good. All right, moving on to number 33. Okay, let's first of all make sure that we have an arithmetic sequence. They want us to find the sum of the first 40 terms. That's a lot of work, okay? So let's be really careful here. First of all, put a 1 in for k, and you'll get out a 5. Put a 2 in for k, and you'll get out a 7. Put a 3 in for k, and you'll get out a 9. Put a 4 in for k, and you'll get out an 11. So it looks like we're increasing by 2. So we do have an arithmetic sequence, and the common difference is 2. All right. Now we have our nth term. We don't have to find that. Okay. Let me show you what I mean. Let me put it to you this way. They want us to find the sum of the first 40 terms. Correct? They want us to find the sum of terms 1 through 40. All right. Now remember I taught you during class, if you were to take 40 minus 1, you would get 39. And I've told you, whenever you subtract those two numbers, always add 1 to it, and that tells you how many terms you're finding the sum of. Don't ever forget that. We're going to use that in a second on number 35 and numbers 35 and 37. So here it's obvious that we're finding the sum of 40 terms. We know that because it's 1 through 40. But when you stop and think about it, you're really subtracting these two, then adding 1. So we are finding the sum of the first 40 terms. So here's my formula. So I'm finding the sum of 40 terms. So n here is 40. Now my first term, well, put a 1 in, and I get 5. Plus, this should be an n, of course, like we've talked about. My 40th term, my last term, is 83. How did I get that? Well, I put a 40 in for n. 2 times 40 is 80 plus 3 is 83. And now I have 20 times 88. 20 times 88, which will give you 1,760. So you found the sum of the first 40 terms. All right, number 35. This is a little different here. Pay attention, please. Watch this. This one's a little different. Now look. Let's first of all make sure we have an arithmetic sequence, okay? If you put 0 in, you get negative 3/4. If you put 1 in, you get negative 1/2. If you put 2 in, you get negative 1/4. If you put a 0, 1, 2, if you put a 3 in, you get 0. If you put a 4 in, you get 1/4. And we are adding, trust me, we are adding 1/4 over and over and over. So we do have an arithmetic sequence. So because we have an arithmetic sequence, we're adding the same number over and over. We can use this formula right here. So let's go ahead and use this sum formula. And here we go. Now first of all, we're finding the sum of how many terms? Oh, I know, 19 terms. Nuh-uh. No. If this was a 1, 1 to 19 would be 19. We have a 0. Remember, you subtract these two numbers. 19 minus 0 is 19, and then you always add 1. If you're finding the sum from 0 to 19, you're really finding the sum of 20 numbers. Trust me. That's how you always do it, okay? So for in here, you put a 20. Now, how do you find the first term? Well, put a 0 in. That's the first number you're dealing with, and you'll get negative 3/4. And now there should be an n. The last term, well, is a 19, right? So put a 19 in. 19, that's to show this is the first term. This is the number you put in for the first term. This is the number for the last term, okay? So 19 minus 3 is 16. 16 over 4 is 4. So we add 4. So we really have 20 over 2, which is 10. And then we have 4 minus 3/4. I'm going to go ahead and make it a decimal. You're going to get 3.25. And then when you multiply that by 10, you're going to get 32.5. The back of the book has 65 over 2, which is the exact same thing as 32.5. Okay, so there we go. Moving on. Number 37. Okay, now let's make sure we have an arithmetic sequence before we use this formula right here. All right, so here we go. Let's put 12 in. 7. This is going to be really annoying. I wish they would have given a small. Let's just use a 1. You can actually use a 1 and a 2 and a 3 just to get a look at it real quick. So I'm going to put a 1 in, and I would get out 3/13. Put a 2 in, I would get out 1/13. Put a 3 in, I would get negative 5/13. So let's see if that's right. Put a 1 in, I get 3. Put a 2 in, I would get a negative. There we go. That's the problem. Okay. So put a 1 in, you get this out. Put a 2 in, you get this. Put a 3 in. Put a 4 in, and you would get negative 9/13. So if you're looking here, guys, we're actually adding the same number over and over. We're adding a negative 4/13 over and over. Trust me, if you keep adding negative 4/13, you'll get the same number over and over. So we do have an arithmetic sequence. Don't be surprised if I throw a curveball at you on a test and give you one that you can't do. Make sure you have an arithmetic sequence, and we do. So since we know that, we can use this formula. So the sum of how many terms? Well, we're going from the 12th term to the 57th term. So 57 minus 12 would be 45. But remember, we always add 1. So we're finding the sum of 46 terms. So the sum of 46 terms equals 46 over 2. And now be careful. The first term that we're going to use is when you put 12 in. So if you put a 12 in for K, you had 7 minus 48 over 13, and 7 minus 48 is a negative 41/13, plus, now your last term would be when you put a 57 in. I'm going to use my calculator for this. So 7 minus 4 times 57 equals, so it would be negative 221 over 13. All right. Now all of this can be a calculator problem. It would just simply be 23, because 46 divided by 2 is 23, and then I would have negative 41 over 13 minus 221 divided by 13, and you'll get out negative 262 over 13, and then multiply that by 23, and you will get out negative 6,026 over 13. Okay, and that is accurate. All right, and that matches the answer in the back of the book. So there we go. Boy, I hope this is making sense. I mean, it's just the same thing over and over. Make sure you have an arithmetic sequence, and if you do, then go ahead and use your formula for finding the sum of an arithmetic sequence. All right, number 39 reads as follows. How many poles will be in a stack of telephone poles if there are 50 in the first layer and 49 in the second layer? So we're going 50 and then next all the way down until you have 6 poles left. So we're finding the sum from 50 all the way down to when I have 6 poles left. Now, obviously we have an arithmetic sequence. We're subtracting 1 over and over and over, okay? So we know, watch this carefully. We know our first term is 50. We know our common difference is negative 1. I know this is my first term. I know this is my second term, and I have no idea what term this is, okay? Let's try to find out real quick. So using my nth term formula, I can find out what term number this is. So watch carefully. For a subscript n, I'm going to put a 6. For a subscript 1, I'm going to put 50. Plus, now I'm trying to find n, so I'm going to put n minus 1, and my common difference is negative 1. So I have 6 equals 50. Negative 1 times n is negative n. Negative 1 times negative 1 would be a positive 1. Combine your two terms and you have 6 equals 51 minus n. Now bring your 51 over and make it negative, and you would have negative 46, negative 45 equals a negative n, and so 45 equals n. So Mr. Garrett, why is that a big deal? Well, I'm going to show you why it's a big deal. You're finding the sum of term 1 all the way to term what? 45. That's 45 terms. Okay? Now, we know the first term is this. We know the last term is 45. So we know that we're finding the sum of all the way from term 1 all the way to term 45. That's 45 terms. So the sum of 45 terms, here's your sum formula down here, equals 45 over 2. What's your first term? 50. What's your last term, or your 45th term? 6. So we have 22.5 times 56, because 45 over 2 is 22.5, and 50 plus 6 is 56. And if you multiply that correctly, you will get 1,260. And that's how many poles you have. That's a little bit of work, but that's a lot faster than adding all of those up. All right, number 41. A gardener is making a planting in the shape of a trapezoid. It will have 35 plants in the front row, 31 in the second row, 27 in the third row, and so on. If the pattern is consistent, how many plants will be in the last row? How many plants are there all together? Okay, so we know we're finding a sum. Well, how many plants will there be in the last row? So we have to find the last term, which makes sense. And then how many plants are there all together? Okay, let's relax and let's not panic, and let's think this through. We know we have 35 in the first row, then 31, then 27, and so on and so forth. Okay, so we know this is our first term. And then we know over here we have to have our nth term, our last term. Well, I think it'd be wise, probably more, I'm not totally for sure, but it'd probably be wise if we wrote our nth term real quick. So my nth term would be, my first term is 35 plus n minus 1. And then my common difference is not 4, it's negative 4. You're going down 4. Now, here's the problem. When I keep going down, and I get to negative numbers, I know I've gone too far. Students, how can you have negative plants? You can't. So if you're thinking, Mr. Arrowhead, how do I know when to stop? It doesn't tell us. Well, you can't have negative numbers. So I'm going to make a wild guess here. Let's make an educated guess. I mean, I guess we could subtract 4 real quick over and over. I guess that would be faster. So that's what we'll do. We'll just quickly subtract 4 over and over until we get down to our last term. So 23, 19, 15, 11, 7, 3. I guess that was faster. So maybe we didn't need our nth term after all, and I apologize. But okay, there we go. So the next term would be -1. Well, there's no way you can have -1 plants. So our first row has 35 plants. Our last row has 3. How many rows? How many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's my 9th term right here. Okay. So A subscript 1. A subscript 9. Now the question said, how many plants are in the last row? We found it. Booyah. That's done. So there's 3 plants in the last row. Now the next thing they ask us is to find the sum. So here's my sum formula. We're going from term number 1 to term number 9. That's 9 terms. So the sum of 9 terms equals 9 over 2. Your first term is 35 and your last term is 3. So plus 3. So we have 4.5 times 38. All right, 4.5 times 38, and you'll get 171, and that's the total number of plants. If you were to add all of these numbers together, you would get 171. These are great problems, guys. They really are. Number 43. If 10 cents is saved on October 1st, and then 20 cents, and then 30 cents, and so on, how much is saved during the 31 days of October? Okay, so our first term is 10 cents. And we're adding 10 cents. Like in other words, our second term is 20 cents. And the 31st day, so our 31st term, we don't know what that is, so question mark. Okay, I am going to use my nth term on this one. I can tell you that right now. Okay, so they're asking us in the problem how much is saved during these 31 days. So you have to add all of this up. Okay, well look, I mean, first of all, I can't add all of these up. First of all, do I have an arithmetic sequence? Yes, I'm adding 10 cents over and over and over. So that part I know. Now I can't really find the sum until I know what the 31st term is. So I'm going to write my nth term real quick, okay? I'm not going to keep adding 10 all the way to 31 terms. That's kind of ridiculous. So my nth term is my first term plus n minus 1, and my common difference is 10 cents. So I want to find out what the 31st term is. So for n, I'm going to put 31. So I have 0.10 plus parentheses 0.31, or not 0.31, I apologize, the 31st term, 31 minus 1 times 0.10. We can do a little bit of this in our head, I do believe. I mean, we can do this in our head. 31 minus 1 is 30. 30 times 0.10 would be 3. So we have 0.10 plus 3. Add those together and you will get 3.10. All right, so there we go. So we know for our 31st term we have $3.10. All right, so the nth term, I wrote the nth term and then I put 31 in right here for n to find the 31st term. Mr. Earhart, why did you need to find the 31st term? Guys, you should know by now, you should see this. We can never find the sum of an arithmetic sequence unless we know the first term and the last term. That's really important, okay? So now we're going to use our sum formula right here. And so pulling that up here, we're going to find the sum of 31 terms. So the sum of 31 terms equals 31 over 2. My first term is 0.10. My last term is 3.10. 31 divided by 2 would be 15.5 times 3.20. Let me grab my calculator real quick. 15.5 times 3.20 would give me $49.60. So $49.60 is how much you would have. All right, pretty cool. There we go. All right, moving on to number 45. All right, number 45 reads as follows. Theater seating. Theaters are often built with more seats per row as the rows move toward the back. Suppose that the first balcony of a theater has 28 seats in the first row, 32 in the second, so on for 20 rows. How many seats are in the first balcony altogether? Okay, here we go. So we have 28 seats, and then in the next row we have 32, and then the next row we have 36. This is A, subscript 1, and it says there's 20 rows, so we're going to go all the way to the 20th row. Bring that down a little bit. There we go. And now let's read the question. I think it says how many seats are there in the first balcony? So how many seats are there altogether? So we're going to add all of these up. Well, first of all, do I have an arithmetic series? Yes. I'm adding 4 over and over and over. Cool, no problem. Now I've got to find this 20th term. Now I'm not going to add over and over. To find the 20th term, I'm going to use my nth term, okay? So let's very quickly use the nth term here. So my nth term would be, well, my first term is 28 plus n minus 1, and then my common difference is 4. I'm adding 4 over and over. Now let's find the 20th term. So it would be 28 plus 20 minus 1 times 4. And let's see, we can kind of do this in our head here. 20 minus 1 is 19, and 19 times 4 would be 76. So I have 28 plus 76, which of course would give me 104. So now I know in my last row, my 20th row, plus dot 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 plus is 104. So I know what my first term is. I know what my last term is. I know that I have an arithmetic sequence, or series, so I can use my sum formula down here. So the sum of from 1 to 20, so the sum of 20 terms equals 20 over 2. My first term is 28 plus my last term is 104. I would have 10 times 132. So it looks like 1,320. And by the way, if I owned a theater and I wanted to know how many chairs there were, I could have done this very quickly and not had to go through and count every chair in the entire place. Okay? All right, number 47, we're finally finished. In an industrial situation, it took 3 units of raw materials to produce 1 unit of a product. The raw material thus formed the sequence 3, 6, 9, because it takes 3 units, 3 units, 3 units. Is this sequence an arithmetic sequence? Well, I mean, this might be the easiest problem we do today. Number 47, yes. I mean, what are you adding? What are you adding over and over? Are you not adding 3 over and over? Sure you are. And then lastly, it asks, what is the common difference? Well, the common difference is 3. Wow, what a letdown. You wait for that last problem. Oh, it's going to be a challenge. That's it. All right. I hope this homework help video has been a help to you. If you have any questions, call me or email me, and I will gladly try to help you. Hope you guys have a good day today.